lines parallel to the same line. When we can say two lines are parallel? If the two line has no common points. The two line has no common points, we can say those two lines are parallel. Say L and M. So we know that L is parallel to M, and there is another line which is parallel to M, and we say M is parallel to N, like some another line is there, means shall we say this L is parallel to N? This one, why you are muting yourself more often? Why don't you leave it as it is? Don't waste time. So L is parallel to M, M is parallel to N. So you can say L is parallel to N. This is parallel to that, that is parallel to another one. So the initial thing is parallel to the last one. How this can be proved? Simply, we'll draw one transversal. You know about transversal, right? Transversal means line which intersects more than one line. It's called a transversal. In this, as L and M are parallel, we can say the corresponding angles are equal. I am naming it as 1 and 2. So, since L is parallel to M, I can say 1 is equal to 2. The reason, corresponding angles. Okay. The same way, also we have M is parallel to N, then we can say this angle 3, the line N made by the transversal, is equal to angle 2. These two are equal. The same reason, those are corresponding angles. And we mark this as equation 1, we will mark this as equation 2. From 1 and 2, what we can imply? From 1 and 2, we can say that the angle 1 is equal to 3. Is it? Also, there is a theorem states that if the corresponding angles are equal, which made by the transversal, then the lines are parallel. So we can say L is parallel to N. This may be like quite confusing to you. There are results that if the lines are parallel, the corresponding angles are equal. On the other hand, if the corresponding angles are equal, then the lines are parallel. Same like 6.1, 6.2. One is converse of another one. Okay, understood or not? If lines are parallel, we can say corresponding angles are equal. If corresponding angles are equal, lines are parallel. Okay, so from this we can conclude that the lines which are parallel to the same line are parallel to each other. So therefore, lines which are parallel to same line are parallel to each other. That is the statement of the statement. Okay. Using this, we will be solving some examples. Have you understood how this proof will be given? Simply we can say these two are parallel means that is parallel. But in this manner only it should be proved. Okay. Then the example 6 point, sorry, example 4. In the example 4, there is a diagram. The line PQ and the line RS. In that there are points X and Y, in which this angle is 135 degree and this angle is 40 degree, and this point is M. We need to find the angle XMY. See, here only two parallel lines are there. You know about the corresponding angles, alternate interior angles, all those property, right? Okay. Then, is any other property can be applied here? No. We can make use of the previous concept, lines parallel to the same line. We will draw one imaginary line which is parallel to both this, and we will name it like AB. Okay. So, for that line AB and PQ, this XM acts like a transverse. Yes. And these two angles are angles in the same side of the transversal. And the property for angles in the same side of transversal is they are supplementary. They are supplementary, not linear pair. Okay. So, 135 plus what will give you 180? 45. 45 only, right? Okay. The same applies for AB is parallel to RS. See, here 40 degree is there. This one, this angle and this angle shares what property? Alternate interior angles are equal. So, here 40 means here also 40. Altogether, our answer is 85 degree. Simply in the diagram itself we can answer. But how will you write? Step by step, whatever the things we have done. Okay. So, I am going to demonstrate how the proof, how the answer should be given. See, draw AB parallel to PQ. Also in the question itself they given that PQ is parallel to RS, then we can say this AB is also parallel to RS. Okay, and from that, since AB is parallel to PQ and XM is transversal, the angle MXQ plus the angle XMB equals 180 degree. In that MXQ it is 135 plus angle XMB equals 180 degree. Then we'll get the answer for XMB as 180 degree minus 35, which is 45. And 135. Okay, and then the other one also AB is parallel to RS, and who is transversal there? MY. MY is transversal. So we can say angle BMY equals angle RYM. Both equals 40 degree. The reason? Alternate interior angles. Here also we should write the reason. What are linear pair? No, not linear pair. Angles in the same side of transversal. Okay. So, therefore, the angle XMY is equal to sum of two angles, that is XMB plus angle BMY. XMB, what we have found? 45 degree plus this 40 degree. So, therefore, angle XMY they asked for is 85 degree. This much process is there. If this question asked in the MCQ, you don't need to write this all in the rough work. Simply you can see the diagram and answer. If it is not in the MCQ but in 2 mark or 3 mark or 5 mark question, this type of descriptive answer should be given. Okay. Also, this type of questions, whenever they ask, the diagram we should draw, whether it is given or not, we should draw. Then we move on to the next example. Shall I erase this? Read the next example. 5. If a transversal, okay, I'll read. If a transversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are parallel. Sounds confusing, right? See, if a transversal, they are talking about the transversal intersects two lines, a transversal which intersects two lines. Let AB be the transversal intersects two lines L and M. Because in the question only the trace is there, we have to draw the diagram. So L is there, M is there, and this guy AB intersect these two. Okay, such that the bisector of pair of corresponding angles, the bisector of pair of corresponding angles, any corresponding angles shall we take? This angle and this angle is corresponding angle, and bisector for these corresponding angles means, bisector means what? That divides the given angle into two equal parts. So this part is equal, this part is equal. They are parallel. These bisectors are what? Parallel. Then we'll name this. This is like some C or D. That also we have to write. Let AC and BD be the bisectors of the angle we should name, right? So ABCD. We'll name this line as EFGH. Bisectors of the angle CAE and that is for AC. Then for BD, ABG. Okay, they are bisectors respectively, and we need to prove they also this AC is parallel to BD, and also AC is parallel to BD is given. To prove this line EF is parallel to GH, then how do we prove that? We'll make use of what is given parallel. First I'll give a walkthrough for this proof, then we'll proceed with the proof. See, since AC and BD is parallel, we can say this half of this and half of this is equal. Okay, since half of this is equal means the other half also what? That makes these two angles equal. And which result we make use of it? If corresponding angles are equal, then the lines are parallel. That is the proof, simply. So, the angle CAE is half of the angle. Why don't we name this also? Because this part would be helpful, right? This part only would be helpful. This upper part, IJ will take many alphabets we are using. Okay, CAE, instead of taking CAE, I am taking CAI is half of IAE, and this are all given. Not given, you can say from that these are bisectors. Okay, and this other half, which half would we will be using? These two corresponding angles are equal, that we are going to say, because this acts like transversal for this. Can you see the diagram? Like in a tilted manner, see for these two lines itself. If that is harder for you, I'll make that easy. See, this like you can see. For this transversal, this corresponding angle and this corresponding angle is equal. And then here, the angle ABD equals half of ABG. That is given. This is 1 and this is 2. And next, since the lines AC and BD are parallel, we can say since AC is parallel to BD, and who is transversal for us? AB is transversal. We can say the angle IAC. Oh, I wrote IAE. Sorry, IAC. IAC equals this angle, the corresponding angle ABD. Then from 1 and 2, this half of IAC is equal to half of ABD. Is it or not? Oh, my bad. CAI and ABD. Then this is correct only now. IAE like that. Sorry. Okay. This IAC is what? CAI, IAC, both are equal. Then this is what? Half of this angle IAE, and that is equal to this ABD is equal to half of ABG. This half, that half will get cancelled. We got our result IAE is equal to ABD, sorry, ABG, which is corresponding angles. If the corresponding angles are equal, then we can say that the lines are parallel. That is it. Using that result, we will conclude this proof. Also, when you see your book, is that same or different? Maybe the alphabets we used is different. The concept is same, but the alphabets we used and the direction we took are different. Just to give you an idea, since the angle bisector is given, instead of that angle I took this one. Instead of that we may take this also. Any one corresponding angle we will take. That is the idea. Okay. Any doubts in this? Okay, good. Then next one. The half of IAE. Board is not visible. Okay. See, after this, we'll be solving all the questions faster. This is the way how you should write. You follow this way. Whenever we say we use this property, which is parallel to which and which is our transversal and which two angles are equal, why those two are equal and why those two are supplementary, that we need to say. Okay. Then we'll see that example 6 as quick as possible. Shall I erase everything?